Operating system support semaphore. Counting semaphore or a general semaphore. An integer value used for signaling among the processes. Only 3 operations must be performed on a semaphore, all of which are atomic, initialize, decrement and increment. The decrement operation may result in blocking of the process and the increment operation may result in unblocking of the processor. So decrementing results in blocking. If the answer goes in negative, then what happens? You block the process from taking place and it will enter inside the queue. Whereas if the increment operation is performed, that means answer is going on increasing, it is coming positive. Then what we do? We unblock the processor and we remove it from the queue. Remove from queue. Binary semaphore, a semaphore that takes values 0s and 1. So what is a decrement operation? A decrement operation will put the process inside the queue and increment operation will remove the process from the queue. Counting semaphore. Counting semaphore can be used to control access to a given resource consisting of finite number of instances. The semaphore is initialized to a number of resources available. Each process that wishes to use a resource performs a wait operation. Wait operation means you are removing something. So you are decrementing the value. You have to remove the resource. Or you can say use the resource. When you perform a wait operation, you use a resource. When you use the resource, what happens? The resource will decrease. So what will happen? When you perform a wait operation, it will be decrementing the counter. So wait operation uses a resource. Uses a resource. When you use a resource, what happens? So suppose the resource, there are 6 resources and you want to use a resource. What you will do? You will perform the wait operation. When you perform the wait operation, you will be remaining with only 5 resources now. So 5 resources means from 6 the number became 5. That means wait operation uses a resource, so it decrements the counter. It decreases the counter. Wait operation will use a resource, thereby it will decrease the counter. When a process releases a resource, it performs a signal operation, increments the value. So when a process releases means it does not need the resource. No need of resource. So when a process will release the resource, now when this process P1, suppose there are 6 resources, process P1 needs a resource. What it will do? It will perform. It needs, what it will do? It will perform the wait operation. When it performs the wait operation, number of resources become 5. Because process P1 is using 1 resource, so what is happening? There is a decrement in the count. Now this process P1 does not need this resource, so it has to return back. Does not need. So when it does not need, it will perform the signal operation to return back this resource. So when it returns this resource, it will come to original number 6. So what happens? A signal operation always increments the counter. When the process gives away its resources, the count is increased. So when it gives away its resources, you perform the signal operation. When it uses the resources, when it needs the resources, you perform the wait operation. When the count for the semaphore goes to 0, all resources are being used. From 6, suppose the count goes to 0. That means all the resources are used. After that, processes that wish to use the resource will be blocked until the count becomes greater than 0. So after this, what happens? All the processes will be blocked who want to use the resource and they will be put inside the queue, because they will have to wait now until the count becomes greater than 0. So operating system support is semaphore. Semaphore is a variable that has an integer value upon which only 3 operations are defined. A semaphore may be initialized to a non-negative integer value. So integer value should be non-negative. That means it should always be greater than 0. If it is less than 0, what will happen? The process will be blocked. If it is less than 0, process is blocked. Process is blocked. The same weight or the weight or P operation decrements the semaphore value. It will decrease the semaphore value. Why? Because resource is being used. Resource is used. If the value becomes negative, then the process executing the same weight is blocked. So if the value becomes less than 0, if the value becomes less than 0, that means the value becomes negative, the process will be blocked. Otherwise, the process continues the execution. So it will be blocked and it will be put inside the ready queue. The same signal or V operation increments the value of the semaphore. If the resulting value is less than or equal to 0, then the process is blocked by the same weight operation, otherwise unblocked. If the resulting value is less than or equal to 0, so again the value is less than or equal to 0, then what will happen? The weight operation will block the processor. Block the processor. What will the weight operation do? The weight operation will block the processor. So this is the thing, weight operation. So this is the weight operation performed. Weight operation, what does it do? It decreases the counter. Weight operation decreases the counter. So while S is greater than, if 0 is greater than S, so S is less than equal to 0, S minus minus, so no operation is performed. If we get this condition where the value, that is the S, is less than equal to 0, what will do? There will be no operation performed. There will be no operation performed and the process will be blocked, and the process is blocked. So for example, you have 6 resources and what you will do, you want to use a resource. So process P1 wants to use the resource and there are 6 resources. Go on performing the weight operation and do S minus minus. So you get 5, then you get 4, 3, 2, 1, 0. At this point, the process P1 is blocked. And what will happen when this process is blocked? We will use the signal operation to increment the value now, so that the resources can be used again. So after this P1 is blocked, what will happen? The signal operation will be performed and signal will increment the value from 0, 1, 2, 3, 4, 5 to 6. So signal increments the value, that means the process gives away its resource. Process gives away its resource. And what does weight do? Weight will decrease the value, that means it will do S minus minus, and when the value of S will be less than equal to 0, no operation will be performed and the process will be blocked. So definition of a semaphore: struct semaphore, int count, Q type you will have to mention. So void sem weight semaphore S. So first operation is a sem weight operation. S dot count minus minus. So what does a sem weight operation do? It decreases the count. So it will decrease the count of semaphore S. If when you go on decreasing, what will happen? The value will be less than 0. If the value is less than 0, then block the processor and place the process in the queue. You will place it in the queue and the process will be blocked. Now what will void signal do? Void sem signal semaphore S, it will increment the value, increase the value of count, increase the counter. If suppose this condition occurs, that is the count will be less than equal to 0, then remove the process P from the queue and place the process on the ready list. Binary semaphore. A binary semaphore only take on the value 0 and 1 and can be defined by the following three operations. So a binary semaphore is initialized to 0 or 1. Binary means only two values, that is 0 and 1. The sem wait B operation checks the semaphore value. If the value is 0, then the process executing the sem wait is blocked. Again, it will check the semaphore value. Value is less than 0 or it is equal to 0 is 0. That means the value is equal to 0. The process will execute the sem wait operation and be blocked. If the value is 1, so over here, if the value will be equal to 0, because there are only two values. So if the value is equal to 0, block the process. If the value is 1, then the value is changed to 0, then the process continues the execution. The sem signal operation checks to see if any processes are blocked on the semaphore. That means the semaphore value is equal to 1 or no. If so, then the process blocked by the sem wait operation is unblocked. If no processes are blocked, then the value of semaphore is set to 1. So if there is a process which is, if the process is blocked, if the semaphore value is equal to 0, then what will happen? The signal operation will unblock the process. Signal operation unblocks the process. If no processes are blocked, then the semaphore value will be set to 1. So in binary semaphores, if the semaphore value is 1, process is continued. If the semaphore value is 0, process is blocked. So in binary, if the value of the semaphore is equal to 1, continue execution. Continue the execution. If the value of the semaphore is equal to 0, block the execution.